Two common technologies that are used for product filled package testing, CCI, are vacuum decay and high voltage. In the case of high voltage, we're subjecting that primary package, that liquid filled package, to a current. And so with the auto-injector, there's a challenge there because that liquid filled package is inside of that device body, so we don't have direct access to it. If we think about vacuum decay, taking that full auto-injector, placing it into a vacuum decay chamber and pulling vacuum, looking for pressure rise over time, there's two things going on there. One, liquid product, especially proteinaceous product, is really, really adept at clogging defect pathways. So for the sake of development and validation, our positive controls, which have known defects in there, frequently are clogged by the product and stop leaking. And so that particular challenge is not unique to auto-injectors, but certainly something that occurs when you're testing liquid-filled products by vacuum decay. The other side of that is that when we subject that auto-injector to vacuum, all of that plastic body is outgassing under vacuum. So any gas or moisture that's trapped in or on that plastic body is going to come off under vacuum. And in some cases, this outgassing or off-gassing, as it's referred to, can introduce noise to the system that makes it difficult to find very small leaks. And so what you wind up at is a place where there's not really a fantastic method for a fully assembled, filled auto-injector. And so how do we overcome that? This is where we start thinking of that product life cycle, that package integrity profile, and what can we do? How can we implement or evaluate CCI or the risk to CCI throughout the different stages of that product life cycle so that we're not just relying on one test at the final presentation to say that everything's good. And so what that might look like for that auto-injection system is performing some evaluation on empty syringes or cartridges in that package design and development phase. Evaluating what we call the inherent integrity. When I put these components together under anticipated manufacturing conditions, do I create an integral seal? Right? So that's, again, package development, empty primary package, but helium, which we might use for that purpose, or headspace analysis, which we might use for that purpose, are extremely sensitive leak test methods. And so what we can demonstrate is that, yes, we're not encompassing the filled product, but when we assemble that package system out of our final components according to our final parameters, I'm creating an integral seal. And so that establishes that base of data to say, unless something falls outside of our design space, this package should be integral. Now we might consider that filled syringe or that filled cartridge. And we might do high voltage leak detection on just that primary package. This might be useful for distribution evaluation. So oftentimes cartridges, syringes are filled in one site and then shipped to another site for final assembly into the device body. Having a validated HVLD method on that primary package, we can do things like evaluate CCI pre and post distribution simulation, going from that primary fill finish to that device assembly location. And then once we get to that final syringe or cartridge inside of that device body, we might move forward using vacuum decay. And we're still going to have those limitations that I discussed previously when we try to develop and validate that final method for the fully assembled filled device. However, because we've done things earlier upstream in earlier life cycle phases, we should have a pretty robust understanding, a robust data set on that package system and its integrity performance. And so that vacuum decay method might be used for testing stability samples, might be used for demonstrating pre and post device distribution that integrity is maintained. But we're not relying on that test for all of the different things or all of the different areas, but we're not relying on that test for all of the different evaluations that we need to make to ensure that that final product, through expiry and use, maintains its integrity.